Okay, let's get into it. Welcome everybody. Once again, my name is Michael Merrington, General Manager of IndEx. So today we're going back in edition on 60079-15 EXNs. Why? It's a very big standard and there has been very big changes. So we're trying to give a bit of history as to how things have changed or why they've changed. One? Okay, very good. Okay, so some of the things are still red and highlighted in here. This is to show the difference of what's been going on between the standards. So what's in red here is actually was in edition 4 and then was taken out in edition 5. So non-sparking, once again. No arcs, no sparks, no hot points, okay? Enclosed break, an internal explosion, which may occur internally without suffering damage, without communicating, meaning without allowing the internal explosion to the external, to spread to the external atmosphere. So it's like EXD. Now, EXNL is not found in this edition. It's found in edition 3. So before 2011, EXNL was still used. But unfortunately, the IECEx standards allows up to 1 edition back. So up until December 2017, people could still technically manufacture EXNL for IECEx use, but for ATEX use, they could not. So EXNL is a lower form of protection than intrinsically safe. Actually, what it is EXIC, 0 faults allowed. So it's feeding a circuit. The barrier obviously would have to be inside of a substation or within a junction box, feeding a specific cable, energy limiting cable, going to an energy limiting device. So some of you will see this before. I believe everybody was already signed up for this course before. So once again, order of precedence, VX documents, certificates, manufacturers IOMs, standards. Let's go to the next screen. Once again, I believe everybody knows all about this. IECEx, nice and easy to find from the website. Just type it in. ATEX, much more difficult. Once again, ATEX considerations. Zone 2, Category 3, manufacturer self-certified. Less trust. Has everybody attended the previous presentation? I believe everybody has. So I want to make sure that I'm not skipping ahead too quickly for that one person that may have not attended in the morning. Is everybody okay with this? Okay. So you guys have seen this before. The major changes. Well, this one brought in a lot of changes. Edition 4, 2011, brought in a lot of changes for motors, evaluations of motors, protection techniques for N, spacing requirements for voltages of over 10 kV, and once again, motors and stators. So right now, this standard, these two still do not exist. These were removed from edition 3. So what are we mainly looking at? EXNA, once again, arc spark proof, no arcs, no sparks, no hot surfaces. NC is not flammable. It's containment and extinguishing of the flame. NL, energy limiting. So the heart of the standard really changes. 4.2, in normal operation and in certain regular expected occurrences specified by the standard, this equipment shall not produce an operational arc or spark unless that arc or spark is prevented from causing ignition surrounding the hazardous atmosphere as described in clause 16 and 20 of this edition of the standard. And develop a maximum surface temperature in excess of the value appropriate to the temperature class of the equipment, unless the temperature on the surface or hot spot is prevented from causing ignition of surrounding atmospheres. Now, manually operated arcing or sparking components within an enclosure that has been considered to be not accessible in normal operation without the use of a tool may be evaluated as EXNA, non-sparking components. Bit of run-on sentences. This standard was very long. There's a reason why they've cut it down. Now, the important part is the maximum surface temperatures were determined differently than Edition 5, 2017. EXNR and NC, only the external surface of the equipment was considered. And, well, that applies to 2017. Now, for EXNA, the surface of any part of the external surface shall be considered, including the surfaces of the internal parts to which the explosive gas atmosphere may access. So if you have an EXNA device, but then you have an NC device that is encapsulated, an encapsulated device, the gas will not have access to that internal device. So it didn't need to be measured for its temperature. But if it's EXNA box with NA terminals, then yes, both the surfaces have to be measured for their temperature. Note, this may be outside the surface of an EXNC component located in an NA. But remember, there's 5 different types of NCs. It's a little too difficult. Now, small components. For the evaluation of small components, you apply 60079-0, general requirements. Now, the temperature relaxations for thin wires and printed circuit boards, what do you know, shall be as per 60079-11. This has been removed in -5. This is a layover from EXNL, energy limiting. Now, IP ratings have completely been removed from Edition 5, but in Edition 4, minimum IP 54 for bare live parts or 44. The interesting one was IP 4X or 2X for insulated parts, and the equipment is in locations providing adequate protection against entry of solid form materials or water capable of impairing safety. That's a big run-on sentence that I feel that would be difficult to assess. Now, then there's Clause 8 and Clause 13. What for? Rotating motors and for non-sparking low power equipment. Then there's IP protection by installation, meaning it could be a random junction box that is not EXE that would provide additional IP protection. So the former standard, this was from 2011. They were still hashing out the standards, trying to figure things out. So now you're going to start seeing these tables that seem to have a lot in common with EXE. So this applies to EXNA, obviously. Creepage and clearance distances and separation. Creepage and clearance distances. So if we're talking 250 volt, we're talking probably just under 4 mil. So it's safe to say 4 mil. You choose your voltage and you follow it. You also have your comparative tracking and then also sealing. As we talked about fly leads, EXNC, a lot of times will have sealing. Well, between there, they also have to have creepage and clearance distances. But for these ones, anything that's above 750 volts VAC, well, there's your minimum degrees of separation. All this has been removed from the standard because NA has become NC. But these are exact copy and paste from 60079-7. Now the interesting one. Take a look at the bottom here. This is a pin crimp. This is a ferrule. Picture not showing up really well there, but pin crimps do not meet the standard. If you really wanted to read through all this, what it says is for connection facilities for -7 for EXE, -15 for NA, -11 for intrinsically safe, -14, they'll call it a core end sleeve. Basically, your terminations have to be good like this. Shall be compact and square, not with damaged insulation like this, misshapen wires, misshapen core, misshapen insulation. We could go through each one of these, but I would suggest you look at IndEx Online webinar number 3, I believe. It talks about, this is all just about making terminations. Shall be a solid shape, shall not misshapen the conductor, shall not misshapen the insulation, shall not spread out the strands, shall be equally solid and equally crimped. So what's the best way to do it? Well, ferrule. Now, what other ones was there? Well, there was connections designed to be used with cable lugs. Such connections shall be in their mountings. Once again, the important thing is avoid loosening and compromising creepage and clearance distances. This one on the left here, I say that compromises creepage and clearance distances, because if you saw this terminal here, they do not enter well into terminals and the wires stick out the end. Well, this one, the entire sleeve up to the collar is in the terminal. Now, connections using permanent arrangements. This is when they're talking about tails. So if you have a tail, you're probably going to need another junction box of another EX protection technique to finish off that one. Then there is also factory connections. It goes on forever. When we go into motors, you'll find that all these are directly from what you would find in the EXE standard, just a few differences. So what does it talk about? IP ratings, glands, dividing boxes, connection facilities, radial air gap. It goes on forever. Another consideration for non-sparking was fuses and fuse assemblies. Well, it's the exact same as EXE. Okay, temperature consideration, make sure it's mounted correctly. Fuse enclosure, you could have a tiny little EXNA fuse enclosure. And when you replace the fuse, it has to be like for like. What about sockets and plugs? Well, it's exactly the same as EXE. IP ratings, that was important. External connections, using the correct reducers, adapters, glands. You shall not use an adapter or reducer with a plug. You shall not use more. You can use multiple adapters or reducers. Perhaps read in the standard about that one. This one was way too big. Luminaires. What do we have? Well, the construction of it, basically, it's talking again about creepage and clearance distances, IP ratings. But the thing is, an EXNA luminaire, usually it had other EX protection techniques in it. M, Q, I. As we talk about fluorescent lights, they're never EXE. So it would never just be EXEC. Same for lighting. You're not going to find an NA light back in the day. It maybe would have been NAQM. So they had their requirements, you know, creepage and clearance, resistance to dust and moisture, just too much to go into. Now, supplementary requirements for non-sparking batteries and cells. Big, huge standard. Or what do we look at? Well, they identified them as type 1, 2, or 3 battery cells. And they said type 3 had no restrictions, permitted activities in hazardous areas, discharging, only discharging. Could not be for charging of secondary cells or additional equipment in the same compartment. So the safest battery type was type 1. There's been a lot of battery banks that there was EEC batteries now. And back in the day, people had EXNA batteries. So if the cell was less than 25 amp hours, it could be used for charging of secondary cells, and additional equipment in the same compartment. Now, supplementary requirements for low power equipment. Low power, this is the EXNL. Or, actually, no, sorry, not EXNL, anything that's under 400 volts. And they're saying that the creepage and clearance distances were very small. We're talking less than 2 millimeters. So what they've done now is they've removed this, and they continue to use the creepage and clearance distance table of -7, EXE, and apply it. So they've reduced the number of tables, and they removed all these things because it was overly complicated. It was just repeating steps from different standards, repeating the same tables again and again. Supplementary requirements for current transformers, where the secondary circuit of a current transformer extends outside of the equipment, the descriptive documents shall draw attention to the need to guard against the secondary circuit becoming an open circuit in service. So what type of transformer would that be? Well, there's some EXNC transformers, no NA transformers, never seen one of those. Now, other non-sparking electrical equipment. If it's not mentioned through clause 8 to 14, it shall meet the requirements of clause 4 to 9 together with any relevant clauses of 8 to 14. That is bloody confusing. It's too much. This is why they changed this. Now, you've seen this one before, but see here, they're missing the EX. Is it EXNC, NC, NC, NR? The former versions of the standards were not the easiest to work with. They've made things better. So what's changed? Well, this enclosed break is still here. And as I explained, that one becomes DC. What's the difference? Well, it's less safe than DB. So you guys would have seen these slides before. So now, if we're talking about EXNL, the whole difference between this would be, okay, if this was EXNL, if it was an ATEX, it would have only been from before 2011 or an existing facility. If it's IECEx, there could have been EXNL still being installed up until December of 2017. So you had NL instruments at the end, you had NL barriers or repeaters, but that NL barrier repeater was EXNA. So the NL device, but NA exterior shell on it, so it's terminals, had to go in an NA box, and the cables fed out to an NL device. This is more difficult than it needs to be. So back to NA. Back in the day when NA was just used, you know, NA wasn't bad. It was easy. But there was so many in ATEX, manufacturers self-certified. So the NA motor, now EC, NA was good. What do you got to use for a gland? D, E, whatever you could find. It was good to go. Same thing for in the terminal boxes. Every component within an EXNA device had to have NA components. So if, let's say, this type of terminal was to be mounted inside this NA or a terminal was to be mounted inside the motor, well, then it would have to be an NA rated terminal. Once again, encapsulation. Well, this one was killed off back in 2011. So even this standard, was it included? No. Yes, this was killed off in 2011. So what is it? Well, it was just their version of encapsulation. We showed you those separation tables. That is with the encapsulating material. Once again, they had dielectric strength testing, same as before. So once again, here's that other installation. This NL device, which is rated NL and NA, must go inside of the NA box feeding an NL instrument. I have seen installations where they only put this into an IP54 box. That is not correct. Or people would assume that the NA device could just go outside because it's rated EXNA. They could not understand that this is a terminal. Terminations are going into it. Hence why cables have to go through a gland. If a cable's not going through a gland, well, if you're going to a terminal and you don't have a gland involved, you got something wrong going on. So we talked about this before. This one would have been an NL device before, not, if it wasn't IA, there would have been an NL version as well, just for zone 2s. So it exactly looked like this. Go inside the box, feeds a flame scanner, proximity sensor, vibration monitoring. Same thing, we've been through these ones. But, okay, what's changed? Well, the things that are in the red are as edition 4, what we're talking about. Anything in the green, disregard. So it said the marking shall also include any marking normally required by the standards. Where is necessary, marking of other standards shall be listed. The marking required, run-on sentence. It just keeps going. If there's any possibility of confusion over the suitability of the equipment, this is to avoid confusion. So the run-on sentence was to avoid confusion. I gotta disagree with their saying there. So warnings. Well, it was under 24, but all these things marked in red. Look at all these different warnings you had to have, depending on which clause reference you were going from. Were you at 9.4? Well, then you better have a warning for don't remove the fuse. We're at 9.35 or 10.1. Warning, do not separate when energized. I would guess that would be maybe EXNL or something left over. 12.528, separate only in hazardous areas. 24.2, do not charge in hazardous area. That's probably batteries. 24.2, do not use primary cells. Yep, batteries. 20.2.722, do not open, maintain, or service, da da da. Hey, what do you know? That's exactly as the, almost exactly as the line below. They moved everything around. I have the red line version of this standard. It is a monstrosity trying to find your way around these standards. So if you're comparing edition 4 and 5, if you don't have 5, you're missing a lot. And if you don't have the red line version, you're missing even more. Because, well, documentation under edition 4 to 2011, information on reduced creepage ingress protection for components shall be listed. The degree of protection when it is provided by the installation. Things were much more difficult back in the day. The basis of compliance of rotating machinery to IEC 60034, including its duty cycle. For motors with a duty cycle, S3 to S10, it's too much. Radial air gap. Information concerning the basis of compliance of luminaires to the relevant subclauses. Information where external transient lighting may are to be provided for non-sparking low power equipment. Information of replacement frequency of gaskets. Okay, that's just been moved down to here because it's a different clause number. I think you guys can get that this was much more difficult. Now, instructions, well, back in the day, it was nice and easy. Just follow the instructions of 60079-0. But in the new standard, they made it much easier. And all those other considerations, such as glands and gaskets and relamping luminaires, having to replace the gasket, they put them under the instructions section and we're done with it. So it seems like the standard got away from all the engineers who were creating it back in the mid-2000s, 2011, and things were really difficult. So the reason that they've cut back on this standard is it was one of the most confusing standards. But manufacturers love this standard, specifically in ATEX, because manufacturers self-certified. It's cheap to make, you sell it, you don't. People sometimes have the view, I don't care, I sold it. I never heard anything bad, nothing has gone wrong. That's what they say. EXNL, that's one that really to go into is more of one that you go into for intrinsically safe. So just wanted to make awareness of it. So this one, so the new standard only has 15 clause references. The one before had 26 and had a whole itinerary of subclauses. So if you go into EXNA Luminaires, that could take another 30 minutes to go through those 1, 2, 3, 4, 5, 6, 7, 6 or so pages. Now, if you don't have access to these standards, if you're working on new installations, avoid it. If you need to work on it, get the redline version, and you'll get edition 5 redline version from the IEC store. Yeah, you can buy the standard online, and then it'll be as if you have edition 4 and 5 at the same time. Then you can see how the history of things has changed. Now, did anybody have any questions? When we go through this, you can see that these tables, these are exactly found in 60079-7. So EX, EB, and EC. So they just add 2 more columns and differentiate between EB or EC. IP ratings, they've removed them from pretty much all the standards and simplified it back in -0. This one, connection facilities, well, they've removed it from 15 and now it's, well, once again, part of EXE. Conductors shall be in a way that they can't slip out, shall avoid loosening, shall make contact that is equal, it's even across the multi-strands, there's positive compression force, constructed in a way not to cause damage to it or change with temperature changes, not specified to accommodate more than one conductor unless specifically designed. Be intended where, if for stranded conductors, employ a means to protect the conductors and distribute the contact force evenly. That doesn't look even to me. That looks oval. That looks much more even. For screw connections, a torque value given by the manufacturer. Unfortunately, 99.9% of people do not use torque screwdrivers. But look what it says down here. Special precautions against vibration, mechanical shock to be considered. Against electrolytic control, corrosion. Special precautions against corrosion should be considered where ferrous materials are used, and limiting temperature of the insulation of terminal blocks. And there's a lot of things to consider. Okay, 30 more seconds and we'll close up. I don't think we have too many questions from people. The hope was for this presentation to maybe get some people from North America, but I still think the time doesn't work out too well for everybody. But it did allow for perhaps going back in time on the standard, and I hope you guys appreciate it. And the big ones that changed: marking, documentation, and instructions. Okay, thank you everybody for attending. Really do appreciate your time. Thanks for, attending this short and sweet session. Thank you very much. Have a good evening and have a good afternoon.